Hello everyone. I am so sorry I'm not in today. I'm not feeling well. I'm hoping that I will feel better tomorrow and I will see you guys on Friday. So we're just going to go through the lesson this way on Edpuzzle. Just make sure you answer the questions, and then when we're finished with the lesson, I'm going to do the class kick. I'm going to have you guys do the class kick, but we're not going to do the pear deck today, so I'm just going to cross those out when we get there. So today is just a continuation of yesterday. We're just adding one extra step. We are multiplying radicals. So the first rule that you need to make sure you follow is that radicals, to multiply them, they have to have the same index. So they have to both be cube roots, both be square roots, both be fourth roots. That's the only way you're allowed to multiply them. And then the rule is any inside numbers get multiplied with other inside numbers, and outside numbers get multiplied with outside numbers. So let's just jump in. We do want to be mindful of the rules from the first day about when we're allowed to have negatives and when we're not allowed to have negatives. Okay, so the first one, they're both square roots, so we can multiply them together. So we're just going to multiply 2 times 8. It stays in the radical because they're both inside numbers. And then you'll just simplify that. The square root of 16 is just 4. Because these are in radical form, you won't need plus or minus signs, because remember, it'll tell you if they want it to be positive or negative. So looking at number 2, it's a cube root, so it's odd. So we're allowed to have negatives under the radical right now. That's fine. So we're just going to go ahead and jump in and multiply them together. It'll stay a cube root. It's a cube root of negative 125. And then that is a perfect number. If we look at our list, that's right here. So that's going to come out as negative 5. You can also type it in the calculator. The calculator will tell you that too. Alright, I need you to be careful with 3, because in 3, it's an even root, and we have right now a negative under an even root. You can't have a negative under an even root. So this one is not possible. And if you read the directions, it says multiply if possible. So this one we are just going to put not possible. So just watch for that. That will happen at least once on your homework. You're not allowed to multiply them even together because that number doesn't exist. It's not real. Alright, and then number 4. This is the first one we've seen where we have outside numbers. So the rule is the outside number gets multiplied by the outside number. So 2 times 3 would give me 6. That stays on the outside. And then we multiply inside number times inside number. That would give me 48. And then this one is not in the list of perfect squares, so we have to go back to what we talked about yesterday and find something from the list that would break it down. 4 does go into it, but there's something slightly bigger, so I'm going to pick that instead. I'm going to pick 16. So we're going to use 16 and 3. And then remember, the one that's from the list will get to break out of jail, so that's going to become 4. Important rule here is we are multiplying those two numbers, so that's going to be multiplication. But the 3 has to stay in the radical. So our final answer here will be 24 radical 3. So that's the basics of multiplying. We got a couple more here. So let's talk about a couple more. Number 5, what you need to notice right away is these are different indexes. If they are different indexes, it is also not possible to multiply them. So if we have different indexes, we are also going to write not possible for this one, because they can't be combined. They have to be the same radical to be able to be combined. Alright, take a second and try number 6 on your own. And I'll have you select the answer on Edpuzzle. Alright, so hopefully this is what you did. Outside number times outside number, we get 10. And then inside number times inside number. This one is okay to be negative because it is a cube root. And then we're looking for a number from the list that goes into negative 120. I believe that is 8. Yep, it's 8. We can break this into, keep the negative with the one from the list. So this will be cube root of 8, cube root of 15. And then we should get 8 times, that's going to turn into negative 2, radical 15. And you get negative 20, cube root 15. Make sure you are keeping the cube on your final answer. So negative 20 cube root 15 is the final answer. And again, we're not doing the pear deck, so I'm just going to cross that off. Alright, looking at this next example, again we are going to multiply it together first. The difference here is there are now variables. So when you're multiplying with variables, if it's a to the m times a to the n, you actually add the exponents. So that's what we're going to see happen today, is we're adding the exponents together to get the total number of x's or the total number of y's. So this just steps it up a notch here. So we're going to do the same thing for the numbers. They're both inside numbers, so we're going to multiply first. 54 times 5 is 270. And then for the x's, we're adding those exponents together. So that's going to be x to the 5th, y to the 7th. I just added, for the x's, it was 2 plus 3. For the y's, it was 3 plus 4. And now we have to look at our list. It's a cube root, so we're looking at our list, trying to find something that goes into 270. Hopefully it's pretty obvious here that that's going to be 27 and 10. And these are just breaking down like what we did yesterday. So then this is the cube root of x to the 5th, y to the 7th. And then we're going to simplify here. So the cube root of 27 turns into 3. The cube root of 10 has to stay under the radical. And then we've got to divide into the exponents. So we're doing, how many times does 3 go into 5? That's 1 time, and there would be 2 left over. And then how many times does 3 go into 7? That's 2 times, with 1 left over. And if you need to do the little long division trick I taught you yesterday to get that, you can. I'm going to start not writing that out, unless I find out that you guys need to see it. Then we'll talk about that on Friday. So that is your final answer. This one does not need absolute value because it was odd. So since it started odd, no absolute value. Alright, so number 2, this one has outside numbers and inside numbers. So we want to do outside number times outside number, that's going to be 6. And then we want to do inside number times inside number, that is going to be 147. And then we get x to the 3 plus 3 is 6, and y squared. So we really want to then focus in on the number. We want to find something from the list that goes into 147. If you kind of keep an eye on the factors right now, this is 21 is really 7 times 3. There's 2 7s that just got multiplied. So I'm pretty sure 49 goes into this. So we want to divide 147 by 49. And you should get 49 and 3 is what that would split into. And then the 6 is still on the outside. And we're going to take care of the variables in a second as well. So then from here, the square root of 49 is 7. You do want to make sure you put times between those because we're going to multiply those outside numbers together now. And then the 3 has to stay in the radical. And then we're going to deal with the exponents. So again, it's a square root. So we should be looking at the fact that we're dividing by 2. The nice thing is these both go in evenly. So 2 goes into 6 3 times. 2 goes into 2 1 time. My final answer here then is 42x to the 3rd y square root of 3. The last step is deciding if there's absolute value. This is an even. It did start with an even root. So we need to see if we have anything that ended odd on the outside. This ends odd, so we do need to put absolute value around those two variables there. Alright, let's try one more. For this one, again, first step, they are the same radical, so we're going to jump and multiply them together. 27 times 6 is 162. And then the x's, again, we're adding x to the 7th. Y, there's really a 1 there on the y that's by itself, so it's going to become y to the 9th. Make sure you are adding 1 if there is no exponent on it. And then we need to go through our perfect fourth numbers over here to find one that goes in. I don't even know off the top of my head, so I'm going to start by dividing by 16. So 16 didn't work. Then I divided by 81, and 81 does work, so 81 is the one we want to use. It splits into 81 and 2. And then we're going to write our variables out here. And then take a second, see if you guys can simplify this one down. Alright, the fourth root of 81 should have changed into 3. Make sure you do take the fourth root of it and not the square root of it. And then we want the fourth root of 2. And then we have to see what happens with our variables here. So the 7, 4 goes into 7 only one time, and there would be 3 left over. 4 goes into 9 2 times, so 2 y's would come out, and only 1 would be left over. And last up here, this was an even root. It started even. So anytime it starts even, we have to decide if we are going to put any absolute value in the problem. The x has an odd exponent of 1, so the x that's by itself would need absolute value in this problem. So that is our final answer. And we won't do that last pair deck problem. I now want you guys to go on Class Kick. The first 2 problems are from what we did yesterday, and then you have 1 problem just to practice to show me how you're understanding what we talked about today. We will talk on Friday about any questions you have on yesterday's homework or today's homework. So we'll catch up on Friday. Alright guys, stay safe. Take care.